Hello students, this is Dr. Sayyed from Sanjuni College of Engineering, Kopargaon. In this class, we will discuss the third numerical example on analysis of two-hinge parabolic arch. The statement of numerical is a two-hinge parabolic arch of span 12 meter and central rise of 6 meter carries a uniformly distributed load of 10 kN per meter. Calculate horizontal thrust. Also find the normal thrust and radial shear at 3 meter from the lead support. Already we have solved two numerical examples on two-hinge parabolic arch. Now here uniformly distributed load is acting full span from A to B. Intensity of load is 10 kN per meter. Span of arch is 12 meter. Central rise is 6 meter. Right? So very first step is similar to previous two problems to find out the vertical reactions at support A and support B. So vertical reaction RAV and vertical reaction RBV. Again, either we can use the basic equations of equilibrium in engineering mechanics, or we can directly use the standard formula. Since the full span load UDL, it means the load is again symmetric over the span. So reactions will be for UDL WL by 2 and WL by 2, where W is equal to 10, L is equal to 12. So we can calculate this as a 60 and 60 reactions. Or we can use the basic engineering mechanics equations of equilibrium, summation of Fy equal to 0. So plus RAV and plus RBV, two vertical reactions, are equal to total vertical load is 10 is the intensity into 12 meter span. 10 into 12, answer is 120. Then if you take summation of moment about point A, then moment of UDL 10 into 12 acting at the center, it means this perpendicular distance is now 6 meter. So 10 into 12 into 6, it produces clockwise moment, so it is plus. Then moment of RBV, it is RBV into 12 meter perpendicular distance, moment is anti-clockwise, so minus, will get RBV from this 60. If you put this RBV here in the first equation, we will get RAV also 60. So we can use the direct formulas also, WL by 2, WL by 2, to find out the vertical reactions. So now we got the vertical reaction at A is 60 and vertical reaction at B is 60. Now horizontal reaction at hinge support is nothing but horizontal thrust, that is H. So now we have to find out horizontal thrust for this problem. We know already we solved two numerical examples. The equation to use to find out horizontal thrust is integration of m into y dx upon integration of y square dx. Now we will find out the numerator first, integration m into y dx. So this is the arch, we got the reactions 60 and 60 here. Now since full span UDL is acting on the arch, in previous two problems if you remember, when point load is acting, we are dividing the arch into two zones, left of point load and right of point load. But now since it is a full span UDL, we can consider a single zone in this arch, that is from A to B. So while calculating the horizontal thrust, need not to divide this arch into different zones, right? Now if you select any point on the arch, we know that how to find out the vertical distance of that point, that is y. So vertical distance of any point on the parabolic arch is equal to y equal to 4h upon L square into Lx minus x square. This is the same formula which we already used in two numerical examples. Now L equal to 12, h equal to 6. So if you put that values of h and L here, we will get the value of y equal to 0.1667 into 12x minus x square. Now to find out the horizontal thrust, we have to integrate from support A to support B directly, because it is a UDL throughout span UDL. Need not to divide into zones, there is only one zone. So 0 to 12 m into y dx equal to. Now if you take a section at any point on this arch, like this, if you take a section, suppose this is distance x, okay. Now we have to take moment about this point. If you consider the left part of this section, this part, okay, now, okay, if you consider the left portion of this section, so we have this UDL, this reaction, that is 60 kilonewton. UDL intensity is 10, span of UDL is x, okay, and this vertical distance is y, that is 0.1667 into 12x minus x square. Okay, now what is value of m here? How to calculate m? So if you consider the left part of this section, now moment because of this 60 first. So 60 into x, this one, then this moment is clockwise. We know that on the left part we are taking clockwise as a positive. Already we discussed in previous two example, and anti-clockwise will be negative. Okay, so 60 into x will be positive. Now moment because of UDL, so intensity of UDL is 10, span is x, so total load is 10 into x acting at the center, 10 into x acting at the center, and perpendicular distance from this point is x by 2. So moment of UDL will be 10 intensity into x span, 10x into perpendicular distance is x by 2. So 10 into x by 2. This is the moment because of UDL. And since it is vertically downward, at this point it produced the anti-clockwise moment. If you look at it, produce the anti-clockwise moment, it will be minus. So 60 into x minus 10 into x by 2 is the moment because of reaction as well as UDL load on the left part of the section. Into this y is equal to, already we calculated here, this is y. So if you put that y here, now 0 to 12 limits and this integration, if you perform this integration either manually or in your calculator, you will get the answer of this integration of m into y dx, and that answer is coming 6912 kilonewton. This is numerator of that formula which we are using for the horizontal thrust. Now if you want to find out the denominator is integration 0 to 12 left support to right support, that is a to b, 0 to 12 y square, y equal to this, if you put this y here, square of that, don't forget integration with respect to x. So if you perform this integration and substitute the limits, the answer which you are getting is 230.4 kilonewton. So using these two integration, now you can find out the final value of horizontal thrust, that is 6912 upon 230.4 equal to 30 kilonewton is the value of horizontal thrust when 2 hinge parabolic arch is subjected to full span UDL of 10 kilonewton per meter. Now again, similar to previous two problems, if you want to verify this answer whether it is correct or not, we can verify with the standard formula of horizontal thrust for UDL case, that is if a 2 hinge parabolic arch is subjected to full span UDL, horizontal thrust is equal to WL square by 8H. W is equal to 10, that is intensity of UDL, L equal to 12 meter, L square, then 8 into H is equal to 6. If you perform the calculation, you will get the answer 30 kilonewton. It means our horizontal thrust value is correct. Okay, so this is the first unknown, that is horizontal thrust. Now remaining two unknowns are normal thrust and radial shear at 3 meter distance from the left support. So we know that if you want to find out normal thrust and radial shear at 3 meter from the left support, first we have to find out what is the value of slope at that point. Okay, so value of slope at this point, that is 3 meter from the left support. The equation we already discussed in previous example, tan theta equal to 4h upon L square into L minus 2x. So h equal to 6, L equal to 12, x equal to 3 meter, which is given 3 meter from left support. If you put all these values, you will get the answer of theta is equal to 45 degree. Okay, this answer is 45 degree. Now if you want to find out the vertical shear force developed at the point where we have taken a section, right, that is Vx. So if you apply summation of Fy equal to 0 at this, in this figure where the section is taken at 3 meter from left support, so 60 is a vertical reaction and minus Vx is a vertical shear force at this point, let it be point D, and then UDL 10 into 3, that is minus 30 equal to 0. So we are getting value of Vx is equal to 30 kilonewton. Now using this Vx, using the horizontal thrust 30 and Vx equal to 30, we can find out remaining two unknowns, that is normal thrust and radial shear at 3 meter from the left support. So first is normal thrust. The equation we already discussed in the previous example, n equal to Vx sin theta plus h cos theta, where n equal to normal thrust, Vx equal to 30 from this step, sin 45 is the slope at point D. Okay, so 30 sin 45 plus h is 30 again from this step, 30 cos 45. If you put the values, you will get the normal thrust value 42.43 kilonewton. Similarly, radial shear at 3 meter from the left support, R equal to Vx cos theta minus h sin theta. So R equal to 30 cos 45 minus 30 sin 45. So value of R is equal to 0. Right? So these are the values of normal thrust and radial shear. Right? So H equal to horizontal thrust is 30, normal thrust is 42.43 and radial shear is equal to 0 when the two hinge parabolic arch with the span of 12 meter, central rise 6 meter, subjected to full span UDL of 10 kilonewton per meter. This is the solution of numerical example. I hope all of you have understand the solution. In the next class, we will solve the another example on analysis of two hinge parabolic arch. Thank you very much.